Chemical properties of carbon compounds. Let us first study about the chemical property combustion. Combustion. In the previous standard, we have studied that carbon in the form of various allotropes on ignition in presence of oxygen undergoes combustion to emit heat and light and forms carbon dioxide. Hydrocarbons, as well as most of the carbon compounds, undergo combustion in presence of oxygen and emit heat and light to form carbon dioxide and water as the common products. Methane is a highly combustible carbon compound which reacts with oxygen to give blue flame, and 213 kilocalorie per molecule of heat is given out. Therefore, this is an exothermic reaction. Methane gas burns completely and the amount of carbon dioxide released during the combustion is very less. Therefore, biogas is used as a fuel. Propane, that is C3H8, is one of the combustible component of LPG. On the complete combustion of propane, carbon dioxide gas, water, heat, and light energy are formed. To learn more about the chemical property called combustion of carbon, let us perform an activity. Let us first see the apparatus and chemicals required to perform this activity. Apparatus: Bunsen burner, copper gauze, a metal strip, etc. Chemicals: ethanol, acetic acid, and naphthalene. Now let us perform the activity. Activity: let us first take a clean copper gauze and add a pinch of naphthalene powder on it. Now, let us hold the copper gauze on the blue flame of the Bunsen burner and observe the flame. We observe that, due to the combustion of naphthalene, the flame turns yellow, releasing smoke, which leads to formation of black soot. Now let us hold a metal strip over this flame. What do you observe? We observe that a deposit of black soot has got collected on the metal plate. Now let us perform the same activity by adding 3-4 drops of ethanol and acetic acid on the copper gauze. We observe that ethanol and acetic acid burn with a blue flame and do not release smoke. From this, we can infer that unsaturated hydrocarbons burn with a yellow flame and release sooty black smoke. Due to this black smoke, a deposit of black soot gets collected on the metal plate. Therefore, naphthalene is an unsaturated compound. Generally, saturated carbon compounds burn with a clean blue flame. Therefore, ethanol and acetic acid are saturated carbon compounds. On comparing the molecular formulae, it is seen that the proportion of carbon is larger in unsaturated compounds than in the saturated compounds. Thus, during the combustion of unsaturated compounds, some unburnt carbon particles are also formed. While in the flame, these hot carbon particles emit yellow light and therefore the flame appears yellow. However, if oxygen supply is limited, then the combustion of saturated compounds also give a yellow flame. Now let us perform one more activity. Activity: let us turn on the Bunsen burner. Now let us open the air hole at the bottom of the burner by means of the movable ring around it. What do you observe? We observe a blue-colored flame. Then let us close the air hole and observe. We observe that the flame turns yellow and releases black smoke. From this activity, we can infer that when the air hole at the bottom of the Bunsen burner is open, there is a supply of oxygen due to which the flame burns with blue color, and when the air hole is closed, there is no supply of oxygen and a yellow, sooty flame is obtained. Always remember, in the gas or kerosene stoves at home, there are inlets for air. Due to these air inlets, the gaseous fuel is mixed with sufficient oxygen and a clean blue flame is obtained. If there is deposition of black soot on the bottom of cooking vessels, then it is an indication of choking of the air inlets and thereby the wastage of fuel. In such case, the air inlets of the stove should be got cleaned. Oxidation. We have seen that carbon compounds, when ignited in the air, start burning by combining easily with oxygen. In this process of combustion, all chemical bonds in molecule of the carbon compound break and CO2 and H2O are formed as the products, which means that the carbon compound is completely oxidized. Some chemical compounds can also be used as source of oxygen. Substances that can give oxygen to other substances are called oxidants or oxidizing agents. Potassium permanganate and potassium dichromate are the commonly used oxidizing agents. An oxidizing agent affects on certain functional groups in the carbon compounds. To learn more about oxidation, let us perform an activity. Let us first see the apparatus and chemicals required to perform this activity. Test tube, measuring cylinder, dropper, ethanol, dilute solution of sodium carbonate and dilute solution of potassium permanganate. Come, let us perform the activity. Activity. First, let us take 2 to 3 ml ethanol in a test tube and add 5 ml sodium carbonate solution in it. Now let us hold the test tube on the burner and warm the mixture. Now in this warm mixture, let us keep on adding dilute solution of potassium permanganate drop by means of a dropper and shake the test tube. The color of the solution is seen to have become pink and disappeared after some time. Why does this happen? In this activity, due to potassium permanganate in the basic solution, ethanol has got oxidized, forming ethanoic acid. Therefore, this is an oxidation reaction. Only some chemical bonds near the functional group take part in this reaction. On starting drop-by-drop addition of potassium permanganate in ethanol, the color of potassium permanganate gets vanished as it gets used up in the reaction. At a certain point of the addition, all the quantity of ethanol in the test tube gets oxidized. If we continue the addition of potassium permanganate beyond this point, it is not used up and becomes excess. So the pink color of this excess potassium permanganate does not vanish but stays as it is. Addition reaction. To understand the addition reaction, let us perform an activity. Let us see the apparatus and chemicals required to perform this activity. Apparatus, test tubes, dropper, etc. Chemicals, tincture iodine, that is solution of iodine in ethanol, bromine water, liquefied vanaspati ghee, various vegetable oils like groundnut oil, safflower oil, sunflower oil and olive oil, etc. Now let us perform the activity. Activity. Let us first take 5 test tubes and label them as A, B, C, D and E respectively. Let us take 2 ml vanaspati ghee in the test tube A and in the other test tubes take 2 ml groundnut oil, safflower oil, sunflower oil and olive oil respectively. Now let us add 4 drops of tincture iodine in each of the 5 test tubes and observe. What do you see? The color of tincture iodine remains as it is in the test tube A, while in the remaining other test tubes, the color of tincture iodine is seen to have vanished. In this activity, from the observation of the vanishing of the color of tincture iodine, we understand that tincture iodine has got used up in the solution in the test tube, which means that iodine has reacted with the concerned substance. The name of this reaction is addition reaction. When a carbon compound combines with another compound to form a product that contain all the atoms in both the reactants, it is called an addition reaction. Unsaturated compounds containing a multiple bond as their functional group undergo addition reaction to form a saturated compound as the product. Unsaturated compounds undergo addition reaction with iodine or bromine instantaneously at room temperature. Besides, the color change can be felt by eyes. Therefore, this reaction is used as a test for detection of a multiple bond in a carbon compound. In this activity, the color of iodine disappears in the reaction between the oils and iodine, but there is no color change with vanaspati ghee. From this, we can conclude that various vegetable oils are unsaturated compounds containing multiple bonds, while vanaspati ghee is a saturated compound. The table given here shows names and molecular formulae of 4 fatty acids separated from vegetable oils. How many carbon-carbon double bonds are present in their structures according to their molecular formulae? Similarly, let us also find out with which fatty acid will the color of iodine disappear and complete the table. Stearic acid is a saturated fatty acid with molecular formula C17H35COOH. The structural formula of this fatty acid does not contain a double bond. Also, the color of iodine does not disappear in this fatty acid. The second fatty acid is oleic acid. This is an unsaturated fatty acid with molecular formula C17H33COOH. It contains one carbon-carbon double bond. Therefore, the color of iodine disappears in this fatty acid. The next is palmitic acid. It is a saturated fatty acid. It has molecular formula C15H31COOH. This fatty acid does not contain carbon-carbon double bond. Therefore, the color of iodine remains as it is in this fatty acid. The last fatty acid is linoleic acid. It is an unsaturated fatty acid. It has molecular formula C17H31COOH and contains 2 carbon-carbon double bonds. Therefore, the color of iodine disappears with this fatty acid. The unsaturated compounds also undergo addition reaction with hydrogen and a saturated compound is formed. But it is necessary to use a catalyst like platinum or nickel for this reaction. A catalyst is a substance due to the presence of which the rate of reaction changes without causing any disturbance to it. This reaction is used for hydrogenation of vegetable oils in presence of nickel catalyst. In the activity using iodine, we have seen that iodine test indicates presence of multiple bonds, particularly double bonds in the molecules of oils. While vanaspati ghee is found to be saturated, the molecules of vegetable oil contain long and unsaturated carbon chains. Hydrogenation transforms them into saturated chains and therefore vanaspati ghee is formed. Unsaturated fats containing double bonds are healthy, while saturated fats are harmful to health. Substitution reaction. As the single bonds CH and CC are very strong, the saturated hydrocarbons are not reactive, and therefore they remain inert in presence of most reagents. But in presence of sunlight, saturated hydrocarbons react rapidly with chlorine. In this reaction, all hydrogen atoms are replaced one by chlorine atoms. The reaction in which the place of one type of atom or group of atoms in a reactant is taken by another atom or group of atoms is called substitution reaction. Chlorination of methane gives 4 products, that is, methyl chloride,
methylene dichloride,
chloroform, and carbon tetrachloride. Chlorination reaction of higher homologous alkanes forms still larger number of products. Now let us learn about the chlorination of propane. In the chlorination reaction of propane, 2 isomeric products are obtained by the substitution of one hydrogen atom, that is, propyl chloride and isopropyl chloride. IUPAC name of propyl chloride is 1-chloropropane and IUPAC name of isopropyl chloride is 2-chloropropane. We have studied 4 types of reactions, that is, combination reaction, decomposition reaction, displacement reaction, and double displacement reaction. The addition reactions of carbon compounds are included in the combination reaction, while the substitution reactions are included in the displacement reaction. The addition and substitution reactions take place at particular conditions. These conditions are indicated on the arrow. After studying about the chemical properties of carbon in detail, let us study about important compounds of carbon.